We are going to prove that our inverses are inverses of each other through composition. Okay. A lot of times, well, I don't know. I call it fog, just because when you write it, it looks like fog. So composition, that's like a little O, which is why I say fog, which means f of g of x. So yesterday, when I gave you my crappy definitions or what you need to think, what did you need to think for composition? It's 3 words. Come on. You wrote it down, or you were supposed to. What is it? Plug it in. Okay? Composition is plug it in. Alright? So, when we're going to prove these two things are inverses of one another, what's going to happen is we're going to plug the inverse function into the original function, and then the other way also. We're going to do it with numbers first, so nobody panic. Okay, so here's the deal. If I give you f of x equals x plus 7, and g of x equals 2x plus 3. Those are our two functions right now. So you can pretend that like this is f of x and this is f inverse of x, but right now we're saying g. So if I want f of g of 4, fog of 4, I can rewrite that as f of g of 4. Now, if I take this f off, and that parenthesis, we're used to seeing stuff like that, right? What am I supposed to do with that 4? Say it again. Plug it in, right? Plug it in where? For x up there. Okay, so that's what we're going to do. So I'm going to take g of 4 and plug it in. So I have 2 times 4 plus 3. So g of 4 is what?
11.
Okay. We plugged it in and got 11. This 11 is the same thing as g of 4. They equal each other. Okay? So we're now going to plug 11 into where g of 4 was. Okay? You confused yet?
No.
Dang it. You are? Yes, I got one person. Don't worry, we're going to do a couple. Okay, so f of 11. Okay, here's your f. Equals x plus 7. What's going to go where x is? 11. So f of 11 equals 11 plus 7. So, composition, what do you got to remember? Plug it in. Plug it in, plug it in. Yeah, it's plug it in. Wasn't that a great definition? Tells you exactly what to do. Okay, so that's with numbers. But this is math class, so we deal with letters too. Okay, so if I do the exact same thing, I'm going to say f of g of x. So now instead of numbers, I got an x. Okay? So that means f of g of x. What is g of x? Up at the top. 2x plus 3. Okay. So g of x is 2x plus 3. Where am I going to plug in that 2x plus 3? Where g of x is. Where g of x is. Because g of x and 2 of x plus 3 are the same thing. Okay? So what I now have since g of x and 2x plus 3 are the same thing, I have f of 2x plus 3. F of x, or my original up here, was x plus 7. Okay? So 2x plus 3 is going to go where this x is. So I have f of 2x plus 3 equals 2x plus 3. That's where x was.
Where'd you get the 7?
Right here. Part of the original. And I get 2x plus 10. Questions, go.
I thought it was just going to be letters.
No, because I got numbers in there too.
How does that prove it?
Yeah, see, I just asked somebody else this. What was I supposed to say? Proves the identity because we end up with the original equals x and the other one equals x. That's what they said. Because I wasn't sure either. So I asked, and that's what they told me. So, here we go. Somebody keeps dinging. Is that me? I'm on silent.
You're starting and stopping the video.
No, I'm not. I don't have that kind of magical power from right here. Stop. Oh, nothing happened. Alright. Okay, so I'm pulling these equations off of your notes. So you don't have to look. I'm gonna write down what you need. So you don't have to flip. Okay? So number 6 from yesterday, my original equation was y equals negative 2/3 x plus 3. Okay? We got our inverse to be negative 3/2 x plus 9/2. Okay, so what I'm going to do is I'm going to plug the inverse into the original. So that means I'm going to go f of f inverse. Or f of that. Okay? So my original what am I going to put in for x if we're doing the inverse? Huh? I'm going to assume you just mumbled the inverse. Probably should have wrote that right there. Is that what you mumbled? Okay. We're not using the calculators for fractions. We're going to learn how to do this right now. What is 2 times 3? What is 3 times 2? What's 6 over 6? We didn't even need a calculator and we multiplied fractions. Okay. That's what I'm saying. So we got x. Okay, so now, negative 2 times 9. Negative 18. 3 times 2. Negative 18 divided by 6. Holy cow, we did it again. Okay, plus 3 right here is coming from the original. Okay, so we ended up with x. That's what was supposed to happen. Okay, that's what was supposed to happen. So now we're going to go the other way. I'm going to take the inverse and plug it in. Okay, I'm going to take the inverse and plug in the original. All right. All right. So I have negative 3/2, and instead of x, we're going to put the original. Negative 2/3 x plus 3. plus 9/2. That's from the original problem up there. Okay, so we're not using calculators because we're smarter than that. 3 times 2 is 2 times 3, 6 over 6. Alright, so I got 1x there. Negative 3 times 3. Negative 9, there's not a bottom number, so it's 2 times 1, so we get 2. So negative 9/2 plus 9/2, that's from the original, and we get x. That just proves that those two things are inverses of one another on your quiz. Okay? Where are your questions here? Notes? Yes, these questions came off of your notes. Do you have any questions on this? No? Okay.